Good morning and good afternoon, everyone. Welcome to join the webinar, Digital Architectonics, a Symbiosis of Bricks and Bytes, the fourth edition of Connected series, which focuses on the best Sino-Swiss collaboration projects and research efforts. My name is Li Bing, and I'm the head of academic relations at SwissNext China, Science Consulate of Switzerland in China. We connect the dots between Switzerland and China in education, research, and innovation.
And now it says me, I'm
Today's webinar is organized in collaboration with Southeast University and ETH Zurich. And we are very privileged to have Chinese and Swiss experts from these two prestigious institutions to showcase their academic and research collaborations in digital architectonics over the decades. Now I'd like to explain one feature of this webinar. At the bottom of the Zoom interface, you can find the Q&A function. So please feel free to type in your questions during the webinar, and we will answer them in the Q&A session. Without further ado, I'm glad to introduce our moderator, Professor Dr. Peng Tang, Deputy Director, Institute of Architectural Algorithms and Applications, School of Architecture from Southeast University. She's serving as the Executive Editor for the Frontier of Architectural Research, Executive Director for the Computational Design Committee of the Architectural Society of China, and a member of National Key Laboratory of Urban and Architectural Heritage. Professor Dr. Tang, the floor is yours.
Okay, thank you, Li Bing. Hello, everyone. Today is also the first day of our advanced lecture series, Architecture Technology, which organized by Southeast University and SwissNext. Our title is the Digital Architectonics, the role of architecture in times of big data and artificial intelligence. So in the following days, we will have 6 lectures which made by the professors from ETH, TU Vienna, and SEU. And so today is the opening of our lecture series, which will made by Professor Ludger Hallstatt and Professor Li Biao. So firstly, let me introduce Professor Dr. Ludger Hallstatt. Ludger Hallstatt is a professor of architecture and CAAD at the Institute for Technology in Architecture, ETH Zurich. And between 1997 and 2000, Ludger Hallstatt was a visiting professor in the Department of CAAD at the University of Culminating, Germany. In 2000, he was appointed full professor at the Department of Architecture at Etihad. And we're glad to know that since 2018, he's a guest professor at the Architecture Internationalization Demonstration of School of Architecture in Southeast University. So now we have many collaboration with Professor Ludger Hagestad Group. Today, the title of his speech will be Artificial Intelligence as a Culture Mirror. So welcome, Professor Hagestad, to give us the first speech.
Okay. Thank you. To share my screen, you have to switch off your screen sharing in Shanghai. Okay, welcome everybody. I can't share my screen if, okay, now I have option. Okay, welcome everybody. I want to give you a short introduction of our background of the collaboration and what I think the programmatics of it is in my point of view. So look at this. I made PhD around this point on machine intelligence in architecture. And we have this curve and this is the prominency of this concept over the years. So you see it came up, it was my PhD was a kind of peak, and now it's getting prominent again. So if you put that to architecture, for example, say smart building, then you see it's kind of mirroring. The absolute values are, of course, different. But if you, and that's the interesting thing, to go to smart city, then you are here. So it's a super prominent concept, and it's getting radically important in the last 10 years maximum. And the key point is not machine intelligence, but big data, if you see that. So I will discuss what this means for architecture and for the kind of research we are doing, because this is very challenging. So let me show. So this is what you expect from a chair in computing in architecture. So we had Dongpeng told that I started in 2000 at ETH. We have 3 different phases. The first, I would say, is empirical phase, the first 7 years. We tried to scan what's going on in computing, and we tried to apply it to architectural practice. This was then founding of several companies, and we had a book with that. You see it here in the background. So all our projects of research are summarized there, and there is a Chinese version of that. The second phase is that we said, as a kind of saturation, we understood how this works. Artificial intelligence and big data in architecture. They made a step back and tried to reason about it's going on. So this is from 2008-10 to 2018. So, and we wrote a lot of, it's reflection and theory. We wrote a couple of books. You can look them up. And currently we are in a phase that we say, we understand the technology, we understand the architectural theory, the principal mathematics, and now we want to reestablish a new kind of architectural thinking. So, and I will talk about that soon. So, prominent So this is our research. To get a picture of it, I can't explain it in this short time. So these are the concepts, architectonics of language. You see, it's always a bit with big data. So we are not afraid of any application in any field. So this is disaster response, machine intelligence, mediating theory, urban, infrastructural ground. This is on language and books. This is on machine learning on the generation of floor plans. You see it just on text. This is on neural control of architectural artifacts. So, and you see these are the things. So it's a lot of them. These are our actual research. So these are the books, just to give an idea. It's not too bad. We have a lot of lectures online. All our classes are online for 3-4 years now, all the lectures, tutorials and so on. We're pushing all education and research online to the cloud. And there will be an atlas on digital architecture coming next month, a very big encyclopedia of what is going on in architecture and the digital soon. So, having all these experience, this is very uncomfortable to hear. And this is what big data and this peak of big data means and is a challenge for. So, machine can design buildings optimized towards users' interest. So machines can do these things automatically to please the customers. So these machines getting better the more they knew about the users. So this is what we experience, and they can do automatic design. So we succeeded in winning a prize in a competition in 2007, I think. With AI making an architectural design, we won a prize for that. Not the first one, but so it was clear that it is clear that machines can do that. And they get better the more they know about the users, and the users get pleased by that. And that's the problem, that's not the solution. This algorithm to do that is short, it's generic, and it works worldwide, and it's always the same. Whatever you're doing, it's the same. Because of that, Google and Alibaba and so on, they all can work in all the domains because it's always the same. So it's very uncomfortable that it's working like that. We can cover all cultures, all domains with the same very simple algorithm just by computing power. Yeah. And therefore the buildings are not generic that we think they're all the same if the machines are doing that. They're as individual as the user's data which is available. So, and therefore people get very comfortable with this idea that the computer understands them and is doing it automatically, which has nothing to do with what we call architecture. So the key problem then is that it's so comfortable with these computers not to do anything. So this is what we're doing in the last 2-3 years. We try to understand this situation and we ask, what is architecture then? If there's a coexistence with this availability, ubiquitous availability of AI. This is what we know. Information technique is a quantum technique. It's a single generic algorithm. And in mathematics, it's a projection from topology to topography, whatever it means. So these very simple things. So in theory and in philosophy, we strongly believe that we are, from Western perspective, in a new renaissance. So we reflect the architecture from 1450 to 1650. They had the same principal challenge as we have. That's very surprising. The mathematics is not contemporary, 1990, 2000, 2010. The mathematics of everything what is challenging us, it's very surprising as well, is from 1880 to 1920, when quantum physics started. That's the thing. Therefore, we think that information technique is a quantum technique, which developed in this time. To understand what's going on, we have to focus on this time. And since 1960, we have Moore's law and quantum printing of energy and information, I would say that, and this is what we experience with these peaks. So it just works since 1960. Before that, these had been the principal concepts. And since 1960, there's no intellectual new idea. It just works in an incredible way. So for architecture, this means technology vanishes. Objects just get new phase. So we don't have a big construction. So everything gets super fine granular. It's towards light. So it's just there. So everything gets very small and tiny. We will have recycling, no ecological footprint because it's recycled and it's a quantum. We will have electricity instead of mechanical solutions. We will have logistic solutions instead of logic, synthesis instead of simulations. The building to be lightweight, smart, adaptive, and fast. And there will be smart nodes in a global network of matter, energy, and information. So this is what we all hear all around. So we are pretty sure that these are the principal parameters. And the interesting thing is that these things have no structure and no form. So there's no architecture. We can't do anything. Therefore, what do we teach? So we want to make our students aware of this situation. And that is an open field of doing things. They have to understand how coding, the mathematics, computer techniques, the standards, and so on works. What is a principal theory? And because it's so generic, the key anchor point. And with that, I'm with my principal interest in the collaboration with my Chinese colleagues, is our cultural heritage. There's nothing else but the cultural heritage because the technology is so powerful and so generic and so simple. Therefore, we have to understand who we are. And we only can do that by facing another culture and facing another language, talking with people of another background. So this, I would say, is the challenging and the interesting point. We have to know how to code. We have to know how these machines work, or this machine works. And then we have to start talking in an interesting way, cross-culture, cross-time. So this is what we want to achieve and to foster. So I think this is my talk. That's it, I think. Thank you very much for your attention.
Okay. Thank you, Luca. And I think maybe our students and the audience will send some questions to you. So next, I will introduce another guest, Professor Li Biao. Professor Li Biao is our professor in the School of Architecture, Southeast University, and the director of Institute of Architectural Algorithm and Applications, what we call the INST-AAA. He obtained an advanced master degree from ETH Zurich and a doctor's degree from Southeast University. During 2009 to 2013, he engaged in postdoctoral research in ETH Zurich. and his research focused on the theories and the methods related to digital technologies for architectural design. Today, the title of his speech is My Exchange and Collaboration with ETH Zurich. So, Professor Livia, please start your speech.
Okay, thank you, Tom Pong. I'll share my screen. Wait a moment. Okay, thanks a lot for the organization of this webinar. Thanks, Swiss Next and Professor Holstadt. My topic is about exchange and collaboration with ETH Zurich, and the title is very, how to say, very simple. So, so before my lecture, I would recall my the short history of my enter the digital field. It was 15 years ago. I was fortunate to participate in academic exchange between SCU and ETH. And this exchange program last nearly 30 years exchange program. And that year when I went to ETH, it was 2004. And I was 36 years old at that year. The funny thing is that year it was May 2004. The De Gaulle airport crashed at that year, and 4 people killed. It was May, and I transferred from Paris to Zurich. It was September, the end of the September 2004, and that was my first time to went abroad. So I even keep the boarding code, boarding card here, and at that time, Bruno Keller, another professor in ETH, he was in charge of exchange program, and he was a building physics professor, and he brought a group of friends engaged in building physics and research on the E flow of HIL building. I think in the E flow of ETH. Sorry, wait a moment. Since I had low working in, I was working in architecture design before I came to ETH, and there is not much rational thinking about architecture physics. So Bruno Keller, I think he didn't thought that I can help him or assist him to his research. So he asked me, here is a brief talking with Bruno Keller at that time. I still remember very clear. It means if you are an architect and you only can design, he thought it means you know nothing. It's a funny talk. the talking indeed how to say, the professor from non-architecture design, maybe he has any misunderstanding of architecture, but indeed we can comprehend the lake of technology in architecture. And Bruno Keller finally asked me to learn English well first, and then considering the next step. I was very regret for my university study. First, I didn't learn English well, and like the talent of learning language. And second is about computer programming. We had a course named Fortune 77 at that time, and I even didn't pass the course examination. And 2 months later, after being introduced by Bruno Keller, for my first time, I entered the crazy, very crazy term of Ludger Hallstatt. And after that time, I experiments the other side of architects' rational thinking, not only emotional thinking of architects. Here is a part of the research in CAD group. I like this slides very much. This person, Marcos is very funny, and he didn't talk much, but he was doing theory of crazy program application, such as the exploration of urban design and architecture design based on Voronoi and genetic algorithms. And this person, Kai, he was my first teacher teaching computer program. And at that time, and he was teaching ActionScript course. ActionScript is a computer programming based on Flash. And Kai, his English is not so good. Fortunately, the program language is a universal language in the world. And then I can seek relevant reference material to solve the program problems. So it's okay to learn to learn ActionScript. And the top right is Christopher Wattman. Christopher has a broad knowledge background, and he studied the program techniques since his childhood, and at that time he's also good at play piano, and very crazy guy. And Odilo Shock, he's the middle person, and then he took care of me, my study for a long time, and often took me to investigate the custom of Switzerland and enjoy Swiss food and so on. And here is in cases done by the crazy team at that time, and the top right is use genetic algorithm to do the bird nest in Beijing. It's how to say, use a program for organize structure of the bird nest. And and here is on the right is I remember it was done by Marcos. It's about how to say, use architecture function and a spatial layout served by self-organization. And in the middle part is research the relationship between architecture layout and sunshine. And this case is very, I think it's very powerful tools. And after that time, I thought I need to do it. And here is a small case done during my postdoctoral research in chair of CAD. I remember maybe it's 2010 years. It's about a Chinese regional house used self-organization, and it's a Huizhou, we call it Huizhou residential house. It's a rule-based case of generative design. So we can get the result just within the several minutes quickly. And the program also think about the courtyard space and proportion and spatial characteristic and architecture style, and also street characteristic. So we can find the its perspective in the left, and on the right is a layout. So with the same traffic system. Okay, so and during my postdoctoral research in Ludger Howestad chair, and any staffs of the chair, they were invited to engage in teaching cooperation with my school. I mean Southeast University. And this picture is Christoph Wattmann, and it's 2010. I remember it's a 2 weeks program or workshop, and the workshop is about generative design and also physical computing. And also for Christoph Wattmann, it was also the first time he came to China, and also the first time he used a chopstick. And yeah. And I think my colleague Li Li, we call Double Li, it was that time Li Li meet Christoph Wattmann. Li Li was a master student in Southeast University, and he was a master of Professor Han Dongqing during that time. But in 2 years later, Li Li went to ETH to continue his doctoral research in chair of Hofstadt. And here is another person, Michael, and we had several teaching cooperation. And it's a picture, Michael talking in TED. And the person in the movie on the top right, named Hua Hao. Now Hua Hao is my another colleague. And Hua Hao finished his doctoral research, also followed Professor Hofstadt. And Benny came to my institute for several times and had lectures. And now Benjamin, he is a pure professor already in ETH now. And at that time, he was a doctor, he was a PhD student in Professor Hofstadt at that time. And even till today, we still have cooperation with ETH, with CAD. Wahid, here's Wahid, had corporate teaching last year. It's a pity this year he cannot come. And we had corporate teaching about deep learning and big data, how to use a technique for architecture design. And then here is I would have a brief introduction of my institute of AAA. And my institute is not so big. He's adding key persons, key staffs of my institute. And was the phone on the top right? The guy now he's having a PhD in chair for Hofstadt. And that's back to architecture. So okay, so the architecture, as we know, architecture is a discipline about function and context, or and form and space, and also structure and construction. Here we can see the two parts. One part is about thinking and design, and another part is about description and drawing. And this description and drawing is about planning and section and layout, or physical models, or even movie, or even perspective. So it's we can divide it architecture into such kind of two parts. One is about thinking and design. Another is about description and drawing. And let's look back at the many software. Let's look back at the many software here that dominated architecture for many years. We can see most of the software are limited to the description and the drawing for buildings. But let's back to these slides. But architecture needs more tools to dominate how to say architecture design methods, and they may be based on the rule-based, case-based, or data-based, whatever. And this kind of how to say the left side about the thinking and design, it needs more information, but the software we are using now for many years is most of the software is about description and drawing. So it's we have a gap between the design and drawing. So so that's why it's the last slides of my lecture. So we are trying to create a tool that need to integrate rational facts with emotional thinking, and treat computer as a the algorithm machine. So the machine, this special machine of computer, they have parallel to a human brain. So they have and the result of the program from the computer added how to change the drawing, computer added architecture drawing to computer added architecture design. And normally the CAD, the concept of CAD is for design, but most of the software now is just for drawing. So we need a tool. We need a tool integrate the rational element of design and emotional facts of the design to integrate the two parts together. And we need also a super function which can serve the most of architecture thinkings or methodology or new methodology. So we are creating such kind of crazy tools. Okay, that's my lecture. Thank you.
Okay, thank you, Professor Li. And we noticed that many audience send their questions to us. So we plan to shift to the Q&A section. may I ask you, there are questions to you and Professor Hofstad and Professor Liebel, please choose the question that you're interested to answer. The first one, I will read it. What do you consider to be the greatest contribution of digital architectonics to traditional architecture? Can you hear me, Professor Hofstad? What do you consider to the contribution?
I think it's yeah, it's an interesting question. Never had that. I don't know. It's very new. So I would say with all these big data, machine learning, and so on, if you don't take that serious and the vertical and towards kind of archaeology, then things will vanish. So it really will dissolve. So all these digital technologies will dissolve whatever there is to a generic soup. So this is what Koolhaas, for example, says it's junk space. And I would say with junk space, with Koolhaas, you can't improve by doing better. So which is a strange paradox. So because there's too much design, there's too much of everything, too much effort, too much of these machines, too much ergonomy, too much empathy, and so on. And by that, everything's flooding away. Architectonics, I would say, is just a different, in my understanding, it's a different understanding than design, than optimizing things. It's just orthogonal to that. And this would preserve, so then try to understand, make an archaeology to what is there, to preserve it and to put it to this new digital world. So the biggest contribution is preservation of our cultural heritage. In strong contrast to digital design, in my understanding, which makes it available everywhere, and by that, all our cultural heritage will dissolve. I don't know whether this is the answer. It's a little complicated, but this question was new.
This question is from the audience that maybe not from the field of our architecture, but many other questions I think is from the students who is studying in the university or will go into the society to find their jobs. The next question is, I think it's from a student. That is nowadays, more and more enterprises are playing important roles in the promotion of technologies, Google, Alibaba, etc. In architecture design, there are also some companies researching on technical innovations such as generative design, smart city construction robot. In this situation, how should universities and enterprises focus their own research fields? Is there any difference between them? I think it's maybe a student. They want to know the. Yeah. In our.
Me again? Or?
Yeah, many companies has do much more research on the.
So this is, for example, there was a reason why we shifted around 2007, 2010 from pragmatic research towards basic research, because we somehow scanned all the different applications, we understood them, we founded companies in the different fields. So there are about 200 employees. It's not too much, but it's okay, especially for a country like Switzerland. Then we understood that in principle, these things are clear and it's not question of research anymore to push it. So this is what we experience now with big data, with smart cities and so on, that companies just doing automatic design on infrastructure and architecture. So universities has to do just something else. So, and this is what I think with this orthogonality,
So therefore, we started writing this book. We tried to understand the theory, the mathematics, and so on. And this, I think, is, and that's a very interesting thing, is this is symmetric in our Western culture to the Renaissance, where all this printing press and Leonardo da Vinci, all these modern times started, and they had the same situation. And this is the birth of architecture. Architecture is always dealing with and kind of domesticating and giving space to live with new kinds of technologies. And we are experiencing that in Western perspective, as we experienced it with, for example, in Renaissance. Therefore, we can learn from this archaeology. And this, I think, is, this is the very thing. This is what I said, we need to learn at universities, the literacy, and we have to reinvent architecture on a digital level. And we can learn from our cultural heritage. And this will be different in Europe from China. For me, it's very interesting to compare that, how our cultures react on that, because the platform, and this is what company is doing, it's all the same. And it's super simple in principle. It's surprisingly simple how this code works.
Yeah. So now we are, again, the Renaissance times to come to the architecture. We still have 10 minutes. Some students want to know something about study in Zurich, in ETH Zurich, in CAAD. So the question is, may I ask, what are the focus of the master's, doctor, and postdoctoral training programs and research works in CAAD Institute of Technology in Architecture Zurich? So there, I also want to know if there are any difference from Professor Lee study in Zurich, in ETH. He studied 10 years ago. So are there any changes?
Okay, yeah, things change, of course, a lot. But in principle, it's like that, if you go in bachelor master, you have in Zurich have a very traditional architectural school. So and you focus very much, and because of that, ETH is famous on the construction of buildings. So Swiss people think that there's no design without construction, without being able to do it. So they don't like fancy stuff which fall apart. So this is the Swiss style, and ETH is famous for that. And in this sense, it's very traditional at ETH, and they don't like to change things. Of course, it's changing, but it's like that. So this is bachelor master. So, and then you have studios with the design studios every semester, with a certain professor, and students learn each semester different. They learn how these professors design, how they think about architecture and so on, and they experience it. So on PhD level, it's so we are starting to have schools, but this is it's a minority of maybe 10% of the PhDs are with certain programs and classes. The rest is just a contract with the professor. So this is a direct relation of a PhD student with the professor and the professor's research interest. So either you have certain projects or certain fundings, and then you have a direct one-to-one relation with the professor, and you have to negotiate with the professor. This idea of a PhD school is not there yet in Zurich, but I'm happy with that. So I really don't like this idea of PhD schools, so which are all around in the Anglo-American system. So, but this is in our school at SL, we have grants, and students with our grants from our department, from our institute, they have to join a kind of school and classes and so on. But I am fighting for a very individual, specific research interest, like we had with Li Biao, a very certain interest, and developing that over 3 to 5 years, and then it's fine. And we don't have classes. Also, I don't like classes, and we have very few at ETH.
Mm-hmm. So I
You're
think
all free to apply. So in principle, if you have a grant, if you have money, so there's no fee at ETH. De facto, it's expensive to live in Zurich. If you find a professor and you have some funding, you're there. So if you have a degree from a nice school like SEU, no problem, yeah. No fee, just money and a topic, then you can do it.
yeah. And I think maybe last question, but another kind of questions are maybe focused on the fabrication, I think. So this audience asked, what's the main bottleneck when incorporating these technologies into architecture industry practice? Is it subject to technology itself or actual manufacture? It's we want to know the technology, how to make the technologies into architecture industry practice, that's buildings, constructions.
Yeah.
And is it the subject to technology itself or actually the manufacturer?
I think it's. I think the key driver, of course, if you're in media, you see all these fancy robots and so on, or these crazy materials and so on, but they are not the driver. So what we have with the driver is it's not so fancy building information models. These are always these nerdy guys who the people are doing that. So nobody wants to be like that as an architect. But even that, it's an indicator, I think, is with big data, with artificial intelligence, it's a problem of logistics. So and logistics will change it. So with that, for example, I think the construction with robots or mass customization and so on, these are all aspects of a radical change from building side towards super logistics like Alibaba, Amazon, and whatever. So Google of how to fit things and put them on site. So I think this will be the key driver. So and therefore I think it's very important to understand coding, to understand what big data is about, where the meaning is, and make sense out of it. So therefore, I disbelieve that it's too important to, for example, to control machines doing that and so on. This is a very romantic idea of what's going on. In principle, it's logistics which is changing the industry. This would be my statement. So it's invisible, which is a little complicated for architects.
Libin, do you think we can another questions, shift to another questions?
Yeah, we still have time for maybe one last question. Yeah.
Okay. So question. Okay. This one is how will the increasing power of AI change the job of architects? Maybe worry about our jobs. Do you foresee a further in which singular buildings could be designed entirely by algorithms? Maybe Professor Lee and Professor Horst can also give us some foresee of this question. The simple buildings could be designed by algorithms. So the architects will lose their jobs.
Yeah, you should answer.
Yeah, when I had lectures, they always have such kind of questions. Many students ask about maybe similar question. Is whether AI can replace architecture. is the key person about it? Tang?
Yes.
Okay. So I think for the technique, it can serve many how to say many about many things about design for the technique, but it has a very quickly calculate and can store many big data, and I think AI technique can instead many part of architecture, in many part of architecture, but it means architect can save their time for another important parts. For example, concentrate on how to say, Ludga, concentrate on I really don't know how to say.
I would say it's a clear yes. Huh? Machines can, if we think in conventional ways, computers will substitute, take over this part. Therefore, I think it's important to have this research on a kind of reinvention what architecture is about. So to overcome these concepts of junk space and so on, where you can't improve by doing better, you have to deal with it. So, and therefore the complicated part is that if everything is solved and everybody is happy, this cannot work. So the complicated part is to understand that this is not paradise. So in our terms. So, and it never works. That there are no problems. So, but the problems of the promise of this technology is if you just follow the machines, then everybody is happy. But this is nonsense. So it never worked in any culture, any time. So something substantial is missing, and we have to find that as architects. And this is, I think, a very prominent and noble a question for architects. So no other discipline can do that like architects. But it's not running with machines or against machines and so on. So it's just another game. So therefore you have to be literate. You have to know how it works and then do something.
Okay, thank you for your answers and lectures. And there are still many questions come to the board, but we can leave our answers to them by through the platform of SwissNext. So, Living, you can show the audience the
Yes. So thank you, Professor Dr. Tang, for your excellent moderation, and also a great appreciation to Professor Dr. Hovestad and Professor Dr. Lee for your available time and your deep insights. So we still have many questions unanswered, so we will transmit these questions to our speakers and also get back to the audience. So also to if you have more questions, then you can also send them to the email address that we show on this slide. Then you are also more than welcome to scan the QR code to follow us on our social media platform. Thank you very much for your active participation, and we look forward to meeting you in our next events. Thank you very much again to our speakers and to the moderator. Thank you very much.
Thank you. And I noticed to the audience that we will have 6 lectures from tomorrow. We will show the code of the meeting to you through the WeChat group. Thank you very much.
Goodbye.
Bye.
Bye-bye.